Chemical reactions are always happening around us. Some of them are fast, while others are slow. For example, the rusting of iron is a chemical reaction. Iron is oxidized in the presence of moisture from the air to form iron 3 oxide. But this is a very slow reaction. The chain in Adamu's abandoned bicycle could take over 20 years before it rusts completely and becomes the brown powder that is iron 3 oxide. The burning of paper is also a chemical reaction. This is a fast reaction. A pile of paper that weighs as much as Adamu's bicycle chain will burn completely in less than 25 minutes. So some reactions are fast and some reactions are slow. Basically, different reactions happen at different rates. The rate of a reaction is the amount of reactants that are converted to product per unit time, and it can be calculated. The amount of reactants is measured in moles. So the rate of a chemical reaction is defined as the number of moles of a reactant that is converted into products per unit time. So to calculate the rate of a reaction, we divide the number of moles of reactants converted by the time taken for the conversion. The time can be measured in seconds, minutes, hours, days, or even years. The rate of a reaction is measured by tracking a particular reactant or product in a reaction. The number of moles of reactants or products converted can be obtained by measuring the mass of a particular reactant that disappears or the mass of a product that appears in a given time, and then dividing it by the molar mass of that particular reactant or product. This means that we can rewrite our formula for the rate of reaction to show this. In chemistry, it is important to know the rate of a reaction. If you are in a lab, you would need to know just how long your reaction would take. It is also important to understand that the rate of a reaction is affected by the conditions of the reaction. For example, if we looked at the rusting of iron, which we mentioned earlier, the chain in Adamu's bike may take many years to completely rust away. But if we were to take the same quantity of iron, place it in salt water, and pass electricity through it, we may be able to completely oxidize the iron in less than 2 weeks. So it is important to know the rate of a reaction and the conditions that can make the reaction faster or slower. You would not want to be stuck in the laboratory with a reaction that could take years, would you? In subsequent lessons, we will understand how to measure and calculate the rate of a reaction. But before we get there, try to remember that the rate of a reaction is the number of moles of a reactant that is converted to products in a unit time. The rate of reaction depends on the conditions of the reaction. I'll see you in the next lesson.